Graph the solution set of 5x minus 3, or absolute value of 5x minus 3 minus 6 equals negative 2x plus 12. So again, remember, the first thing we're going to do is try to get the absolute value bars by themselves before we split it into the two cases. So there's only one thing to do to get the absolute value bars by itself here, and that's going to be to add 6 to both sides. So I put the 6 under the 12 because they are like terms. So the 6's cancel. So that's going to give me absolute value of 5x minus 3 equal to negative 2x plus 18. Then we check our two cases. We have case number 1, which is absolutely no change. It's just going to take away the absolute value bars. So 5x minus 3 will be set equal to negative 2x plus 18. And then the other case is 5x minus 3. We're going to set it equal to, change the signs on the second part. So we're going to set it equal to positive 2x minus 18. We're going to solve both of them separately. So back on the left case, I should add this 2x to both sides. I got to get the x's on the same side again. So 7x minus 3 equals 18. I'll add 3 to both sides. So we get 7x equal to 21. And then divide by 7. We divide by 7, we get x equal to 3. That's a potential solution. And now let's do the one on the right side. So on this one, that means I will subtract 2x from both sides. So that will be 3x minus 3 equal to negative 18. Add 3 to both sides. So 3x will equal negative 18 plus 3 is negative 15. Divide by 3. And so potentially we have a solution over here of x equal to negative 5. But we won't know if those are actual solutions or not until we check the answers. So on the left side, I will replace all of my x's with a 3. So I'll have 5 times 3 minus 3. Absolute value of all that, minus 6. We are testing to see if it really equals negative 2 times that potential solution of 3 plus 12. Do what's inside of the bars first. That's going to be 5 times 3 minus 3. That's 12. So the absolute value of 12 minus 6, does that really equal negative 2 times 3 is negative 6 plus 12. The absolute value of 12 is just 12. So is 12 minus 6 equal to negative 6 plus 12? 12 minus 6 is 6. Negative 6 plus 12 is also 6. So this checks. And now test if x equals negative 5 is an actual solution. So we do 5 times, replace the x with negative 5, minus 3, minus 6. The absolute value of all of that, minus 6. Does that really equal negative 2? Replace that x with negative 5, plus 12. So when we do what's inside of bars on this one, we'll have 5 times negative 5 is negative 25, minus 3 is negative 28. Minus 6, does that really equal negative 2 times negative 5 is positive 10, plus 12. The absolute value of negative 28 is 28. So does 28 minus 6 really equal, and we can go ahead and add 10 and 12 together, does it really equal 22? Well, 28 minus 6 does equal to 22. So this also checks, which means the two solutions that we got are actual solutions of x equal to 3 or x equals negative 5. We'll place points on the number line on those. So here is a point on -5, and here is a point on the 3. Here's another example, example number 2. It says extraneous solution. I wonder what's going to happen here. We are going to solve this. It's 2x plus 1 minus x equals 3x plus minus 4. And again, check your solutions. So, we got to get the absolute value by itself. So in this particular case, to get the absolute value by itself first, I'm going to add this x to both sides. And that will be 2 absolute value of x plus 1 equals 4x minus 4. And then I'm going to divide by the 2 that's outside of the absolute value bars, because that's 2 times the absolute value of x plus 1. So canceling that out will be dividing by 2. Didn't mean to cancel it out that way. I meant to do a little slash there. There we go. So we get the absolute value of x plus 1 equal to 4x minus 4 is going to be 2x minus 2. So we're going to split this up into our 2 cases. We have the first case, again, no change except just take away the absolute value bars. So that's going to be x plus 1 equal to 2x minus 2. That's case number 1. And then case number 2, that's when you're going to have x plus 1 equal to, and we change the signs on the second part, negative 2x and plus 2 now, and solve them separately. So to solve the first one, I think what I'm going to do is I'm going to subtract this x from both sides. That will give me 1 equal to 2x minus 1x is just 1x or x minus 2. And then add this 2 to both sides, and this will solve for x. I'll get 3 equal to x, which I could flip around to be x equal to 3. So that's one potential solution. And then the other potential solution in this case, because I like positive x's, so that's why I'm going to do it this way. I'm going to add the 2x to both sides here. So that'll give me 3x plus 1 equal to 2. I'll subtract 1 from both sides. That will give me 3x equal to 1. Divide by 3, and my other potential solution is going to be 1/3. And you're not going to want to round, because if you round and check your answers, I promise you it's not going to check out. So if the answer is a fraction, you have to leave it as a fraction. So we have to check our solutions and make sure that these are actual answers. So on the first one, we'll replace the x's with a 3. So we will have 2 times, replace that x with a 3, plus 1, minus, replace that x with a 3, and we're checking to see if it really equals 3 times replace that x with a 3, minus 4. So that would be 2 times the absolute value of 3 plus 1 is 4, minus 3. Are we checking to make sure it's equal to 3 times 3 is 9, minus 4. Absolute value of 4 is just 4, so this becomes 2 times 4 minus 3. Does that really equal 9 minus 4 is 5? 2 times 4 is 8. 8 minus 3 is 5, so 5 does equal 5. So yes, this checks. So 3 is the solution. So now we're going to test to see if 1/3 is a solution. So I'm going to have to replace the x's with 1/3. So this will be 2 times the absolute value of replace that x with 1/3 plus 1. Close my absolute values, minus 1/3. Does that really equal 3 times 1/3 minus 4? So 1/3 plus 1 is 4/3 minus 1/3. Does that really equal 3 times 1/3 is just 1? Does that really equal 1 minus 4? Absolute value of 4/3 is just 4/3. Minus 1/3, does that really equal? 1 minus 4 is just -3, so the right side is already simplified. The left side, when you take 2 times 4/3, that is 8/3 minus 1/3. Does that really equal -3? 8/3 minus 1/3, that is only 7/3. And that does not equal -3. This does not check. We have found an extraneous solution. We did nothing wrong, but just sometimes the solutions to absolute value problems that you get do not fit the original problem. So there's actually only one solution to this problem, and the only solution is that x equals 3 that we had from the left side, the left case. Let's look at example 3. It just says empty set. So we're going to solve 4x minus 7 plus 10 equals 2. So again, the very first thing, get that absolute value by itself. So we will subtract 10 from both sides. And you get absolute value of 4x minus 7 equal to -8. Well, what do we know about absolute value? What we know about absolute value is that absolute value is always positive. The absolute value of any number is always going to be positive. Well, we have an absolute value that is set equal to a negative number. The absolute value bars are still there. This is before I've even done the split. So, since I have an absolute value set equal to a negative and absolute values must always equal positive, there is actually no solution to this problem. We will never find a number we can plug in for x and expect to get an answer of -8, because anytime we plug a number in for x and then take the absolute value of the result, we'll always get a positive answer. So that's not possible. So this is a no solution, or remember, a way to write no solution is a O with a slash through it. That's the empty set. Let's try the one directly below it. You can see it's -5 times the absolute value of 7x minus 2 plus 3x equals 3x plus 10. So let's start out by getting the absolute value by itself. And I think the best way to do that would be to subtract 3x from both sides. So that'll be -5 times the absolute value of 7x minus 2. 3x is actually cancel on both sides. That's awfully nice. So it equals 10. Then I'll divide both sides by -5. And I have the absolute value of 7x minus 2 equal to -2. 10 divided by -5 is -2. Should I split this up? Should I go further? I should not, because just like the previous example, I have an absolute value set equal to a negative number, and that is simply not possible. So here is another one that is a no solution or an empty set.